Hey, how are you? So I have just updated my logic decision tree thing. I added AND operation to check for truth values inside the array of the JSON configuration, and I wanted to check if it's kind of fast, right? So I also added the variable extraction from context. So I could provide some object with deep values inside the object, yeah. And I wanted to test if my implementation is kind of fast against the original JsonLogic package inside JavaScript. Like JsonLogic exists in JavaScript. So I created a small project that literally has the same configuration over here for the logic and with the same context, right? And I already prepared like a timer to see if just to see the time difference. And also for my Rust thing, I ran it already, so I kind of know cargo run how it works in debug mode for Rust. It actually doesn't register any milliseconds at all, and node index.js, well, it registers some picoseconds, right, or whatever. So less than a millisecond, but that's for one run of the thing. You know what? Actually, before I create a for loop to execute this a bunch of times, so let me just show you the result of the execution so that you know I'm not bullshitting you. Println. So this is supposed to show the result. What was the syntax? I think I could do this. Yeah, I think that was it. So yeah, it shows me that the result is a primitive of Boolean. It's true, and this is a serializable value. And the same for this. Let's const it out. Res equals to whatever that is, and the console log res is res. So technically this should also result into truth. So now that you know that the thing is functional and it is accessing internal variables inside there, let me undo that, yeah, get rid of result. I really want to execute that a bunch of times. So for, let's say, from 0 to 1,000, yeah. Oh, for something I don't want to have in 100. So how fast will it execute 1,000, like the same operation 1,000 times? And here also for let I equals to 0, I is less than 1,000, I plus plus brackets, and this. Oh, all right. So the loop count is supposed to be the same. And let's run it again in debug mode for all you people who point out obvious stuff to me. What? Oh, I didn't save. So now it takes 8 milliseconds to run this thing 1,000 times in Rust. This is Rust. And 1,000 times in JavaScript, in Node.js. Well, it takes significant amount. Well, it's almost on par with Rust in debug mode. And if I run it in release, it takes 1 millisecond consistently. Well, this is interesting already. So if I increase that to 10,000, no, let's make it a 100,000 loop. Paste it over to JavaScript as well. All right, let's see how JavaScript handles it. 180 something, 190 milliseconds almost consistently. And yeah, let's run in debug Rust as well. Well, obviously in debug mode Rust is just painfully slow over here. It's significantly slower than JavaScript, but in release mode, once all debug information is removed from code, well, it is still significantly faster, like 60 milliseconds consistently faster. So yeah, 60 milliseconds is quite a lot, especially if I wanted to run this in a game. So let's say if this was a real-time strategy, I would have maybe at least 50 characters on screen, and each of them would run like this or significantly more sophisticated logic, like here, right? It means that 60 characters would let's see actually. If I had 60 characters executing the same kind of logic to decide a bunch of things, they wouldn't consume too much time every second, 60 times per second in a game loop. So this is really fast. Whereas JavaScript for 60 characters, every frame, it would take a millisecond. So 60 characters, but that's only logic part, where what they want to do. And there might be pass fighting stuff in between to decide more stuff. So it's actually beneficial to have more, like less time consuming execution for all the logic stuff. Again, if there's 100,000 items that could run in a game which is not realistic, but still for MMORPG this would all be handled by actual players. If I was to again implement all this for a real-time strategy, I would have like 160 or 100 characters. They would all execute some logic almost every frame, maybe with some scheduling. This is way more beneficial. Yeah, Rust is really fast. Well, I guess it's also not consuming as much memory. I don't know how to test memory consumption in a JavaScript version. So yeah, that's that. But to tell the truth, the speed is not that much different. And the main thing that is probably slow is this part where every time we execute this logic, the string has to be processed. We are supposed to find the path to a variable, so we split string by point and we enter the context by challenger, and then by name we find the value and we compare against strings. So maybe if I opt out this piece of logic and remove this for a while and remove that, let's see if these things, simple operations, perform literally on the same speed. So this elapsed significantly faster already because we are not comparing strings and stuff. So without the string operations, Rust is like twice as fast, even more. So that's cool. So that means that if I ever decide to use reading stuff by strings, then I shouldn't do too much of that, because this consumes a lot of CPU cycles. I mean, yeah, it's 3 times faster without string comparisons. So yeah, of course Rust is fast because it compiles my JSON logic into a specific enum that knows how data looks like, and it's able to squeeze out a bit more performance, whereas JavaScript, well, this is an object and there is a possibility to extend the objects, like with the prototypes and stuff like that. So of course JavaScript will be slower, but it's faster to prototype. So that's that. But I'm still surprised that it performs so many operations in so little time. I would never have in some sort of web browser game 100,000 characters that do some things with this logic. Yeah, but eventually I do envision that JSON logic part for decision making could have a proper UI to come up with logic strategies, but for future episode I will probably introduce some sort of JSON schema to validate all these things for me to develop. Well, here we go. Process faster. This is obvious, and I'm happy to see that I'm on the right track. See you next time.